9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
As the Soviet Vostok 1 spaceflight began its descent back to Earth in April of 1961, cosmonaut Yuri Gagarin officially became the first human in space. However, in only a matter of seconds, his module started gyrating uncontrollably. As he looked through the window, he could spot Africa, then the horizon, then the sky. Gagarin was quickly losing vision and getting dizzy, and it seemed like his spacecraft would not survive re-entry. The legendary cosmonaut eventually touched down on Earth safely, but the Soviet Union would closely guard a series of strange events leading up to that historical moment that would only come to light a decade later. After launching several precursing uncrewed missions between May of 1960 and March of 1961, the Soviets claimed to be ready to send the first man into space. The spacecraft's final design, Vostok, was somewhat rudimentary, with two main components: a descent module with a pilot cabin inside, and an instrument module equipped with a braking engine. On April 12, 1961, at 4:10 a.m., cosmonaut Yuri Gagarin boarded Vostok 1. He was relatively calm, chatting with his supervisors and even requesting music on the radio. German Titov, Gagarin's backup, often complained of chest pains, but Yuri was so relaxed that he showed a pulse of only 64 beats per minute, according to official reports. Despite an initial delay due to a malfunctioning hatch, at 6:07 a.m., Vostok 1 took off from the Baikonur Cosmodrome. The flight's simple mission was to reach the upper atmosphere, make one orbit around the Earth, and come back with a safe landing. While the cosmonaut looked out a small window near his foot, he remained in good spirits, and the flight continued without any significant hurdles. Vostok 1 would successfully beat the Americans and change the world forever. According to official Soviet literature and records, Gagarin and his Vostok landing capsule arrived with the cosmonaut inside it. However, there was no official explanation as to why Gagarin landed on a field where no one was there to greet him. After the flight's report was published by the Soviet Union, several witnesses denied any problems during re-entry and tried to explain the strange occurrence by attributing Gagarin's confusion to adrenaline and the heat of the moment of separation. However, that information was far from the truth, with the real reason being that scientists twice miscalculated where Gagarin would land, and in fact, Vostok had never been designed to land with the cosmonaut inside. As Gagarin flew over the North Pacific Ocean, the sun was still down. However, as the Vostok spacecraft crossed the Strait of Magellan at the very tip of South America 23 minutes later, the sunrise was beginning to emerge. Another 25 minutes later, as Gagarin looked at Africa through the small window, the spacecraft's automatic systems adjusted the vehicle into the required settings for the retro-rocket firing and subsequent return to Earth. As Gagarin and the Vostok prepared for re-entry, it was all going according to plan. Until it wasn't. After completing the 40-second burn of the braking engine to slow down the craft and prepare for re-entry, a valve within the braking engine failed to shut entirely, thus leaking fuel. Consequently, the engine ran out of gas and shut down earlier than scheduled, slowing down to 132 meters per second instead of the planned 136. Although this speed was enough to push the craft towards re-entry, the command to shut down the engine was never issued by the system because of the craft's failure to reach the pre-programmed speed set by the engineers. As a result, the engine's propellant lines remained open after it ran out of fuel and stalled. The pressurized gas and oxidizer then continued to escape through the main nozzle and steering thrusters, causing the spacecraft to spin uncontrollably. While the aircraft was still spinning with no way to stop it, Gagarin was faced with yet another problem. The re-entry module had not yet separated from the service module, which was supposed to happen seconds after the burn ended. The re-entry module was carrying the cosmonaut and was designed to fall back to Earth, while the service module burned up in the atmosphere. Inexplicably, the module remained attached and was held together by a bundle of wires. As both parts made their way towards the Earth, the modules finally detached at an altitude of 492,126 miles, and Gagarin's pod settled into the proper re-entry trajectory. Descending at extreme G-forces, the cosmonaut's muscles began to tear, and Gagarin fought to remain conscious. Gagarin braced himself and was eventually ejected from the spherical module. His ejection seat then came loose and finally deployed his parachute only 8,200 feet from the ground. 10 minutes after ejecting, the cosmonaut landed safely in an open field with freshly plowed soil cushioning the fall. Landing a whopping 186 miles away from the designated landing site, both Gagarin and the spacecraft ended up southwest of the town of Engels, in the Tarnovsky district, where bewildered locals saw the cosmonaut emerge from the fields. When a local commander of the anti-aircraft division in the area spotted the falling spacecraft, he quickly rushed to the landing site and drove Gagarin to his unit, telling his superiors about what had just happened. The International Astronautical Foundation, a non-governmental and non-profit organization, was established in 1951 to provide aeronautical and astronautical activities around the globe. One of its many duties was verifying record-breaking flights through the official guidelines. Back in 1961, the organization established that the pilot had to land inside their craft for a spaceflight record to be valid. This rule, carried over from aviation, became a problem for Gagarin because he did not land inside his spacecraft, which was the intention from the beginning. As a matter of fact, Soviet space engineering experts hadn't yet perfected the braking system that would slow the craft enough for a human to survive the landing, and the cosmonaut was always meant to eject the module. Days after the flight, Russian space program officials filed the official report to the International Astronautical Federation, going to great lengths to conceal the fact that Gagarin did not technically qualify as a record setter. Soviet officials even went as far as making up a spaceport near where the cosmonaut had landed, all while pressuring Gagarin to lie several times during press conferences. German Titov finally got his own spaceflight mission only a few months later and became the second person to orbit the Earth and the first to spend 24 hours in space. But unlike Gagarin, Titov spoke the truth, and he owned up to ejecting himself from the module. This confession led to an urgent special meeting between the International Astronautical Federation delegates to re-examine their rules. The result was that the organization finally recognized that the only crucial elements of record-breaking spaceflight were the launch, orbiting, and safe return of the crew, no matter the kind of landing. The first official admission of the truth behind Yuri Gagarin's Vostok 1 landing came in 1971, at a time when his flight had been widely accepted as an international record, and 2 years after his passing in a tragic accident. However, the back and forth regarding the facts of the ever-mysterious Soviet space program do not change the reality of Yuri Gagarin's accomplishment. Vostok 1 was a successful mission that took the world by storm. As astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon on July 20th, 1969, former President John F. Kennedy's pledge delivered 8 years earlier in his infamous speech before Congress was finally coming to life. However, the last part of the assignment was yet to be fulfilled. The astronauts from NASA's Apollo 11 mission needed to get back home safely. The pressure was exorbitant, as any malfunction, as insignificant as it may be, could result in Armstrong and Aldrin getting stranded in outer space. Back on Earth, President Richard Nixon's staff asked his speechwriter to prepare a statement in case a catastrophe were to happen. William Safire quickly complied and ultimately delivered an emotional address that was aptly titled "In Event of Moon Disaster." On May 25, 1961, the youngest elected president in United States history, John F. Kennedy, attended a joint session of Congress and delivered a rousing speech calling for all Americans to unite in one common goal, to land an American on the moon. Quote, "This nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth." It was the beginning of Kennedy's presidency, also known as the Age of Camelot, and the American desire to find peace and avoid war was increasingly latent. However, that dream was short-lived, and in early 1962, Kennedy had to resist the failure of the CIA's Bay of Pigs invasion of Cuba. More importantly, Kennedy had to use every ounce of charisma he had to confront the Cuban Missile Crisis, which put the United States and the Soviet Union at the brink of war. And to make matters worse, the president also had to deal with the escalation of the conflict in Vietnam, where the communists were about to take over the country. Still, Kennedy was committed to achieving world peace and helping his country win the space race against the Soviets. On September 12, 1962, Kennedy once again addressed the American populace, quote, "We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard." Despite all his efforts to support NASA by increasing its budget by almost 80% and proposing the Soviets a joint mission to the moon to ease the tensions of the Cold War, President Kennedy would not live to see his dream realized. After the president's assassination, the responsibility fell to Lyndon B. Johnson, followed by Richard Nixon. That historic day, on July 20th, 1969, an anonymous citizen placed a bouquet of flowers on Kennedy's gravesite in Arlington with a note that read, quote, "Mr. President, the Eagle has landed." The success of the Apollo 11 mission was Nixon's biggest triumph in a time of incessant chaos. The withdrawal of American troops from Vietnam, the escalation of peace protests in the U.S., and the Watergate scandal were all a heavy blow to a troubled presidency. However, Nixon fulfilled the promise Kennedy made to the Americans of landing not just one man on the moon, but several. All 6 American lunar touchdowns, from Apollo 11 in 1969 to Apollo 17 in 1972, occurred during Nixon's presidency. Still, these victories did not come without their set of risks, especially regarding Apollo 11. Before that mission was launched, NASA and the presidency were very concerned about it. And just as they expected, several minor mishaps had Houston on high alert. One of NASA's biggest concerns was missing the mark on touchdown, despite multiple alarms that signaled Armstrong and Aldrin that they were going off course and running out of gasoline. Although Houston was relieved when Armstrong announced that the Eagle had landed with just 30 seconds left of fuel, the mission was only halfway done. The men had to safely return to Earth now, and this was the hard part, as sensors indicated that there was a pressure buildup in the landing engine fuel line that could trigger a lethal explosion. Fortunately, the gas was released, and there was no explosion. Once the mission on the moon was over, and Aldrin and Armstrong got ready to come back home, a broken-off circuit breaker almost left the 2 men stranded in outer space, as the device was pivotal in igniting the ascent engine properly. After a night trying to find a solution with mission control, Aldrin was finally able to push the circuit back in place with a felt-tipped pen he was surprisingly carrying in his shoulder pocket. As minor inconveniences kept piling up, NASA and the presidency contemplated a worst-case scenario and started making the necessary preparations in case of a catastrophe. It would take 2 decades for a hidden Nixon speech about Apollo 11's potential failure to come out to the public. 1 month before the launch of Apollo 11, astronaut Frank Borman, the liaison to the White House, told senior speechwriter William Safire, quote, "You want to be thinking of some alternative posture for the president in the event of mishaps, like what to do for the widows." Safire was later told by White House Chief of Staff H.R. Haldeman that he had to pen a presidential address in case Armstrong and Aldrin did not make it back safely. Inspired by several drafted speeches about the possible negative outcome of successful operations such as the landings of D-Day, Safire finished the speech on July 18, 1969. It was titled "In Event of Moon Disaster." The speech that no man surrounding the president ever wished to hear was eventually brought to life as part of a project developed by MIT engineers. Using deepfake technology to construct a news broadcast in which a digitally reconstructed Nixon delivered bad news was no easy task. Still, it achieved the intent of illustrating to the public the dangers of fake news. Nixon begins his speech by saying, quote, "Fate has ordained that the men who went to the moon to explore in peace will stay on the moon to rest in peace. These brave men, Neil Armstrong and Edwin Aldrin, know that there is no hope for their recovery, but they also know there is hope for mankind in their sacrifice. These 2 men are laying down their lives in mankind's most noble goal, the search for truth and understanding. They will be mourned by their families and friends. They will be mourned by their nation. They will be mourned by the people of the world. They will be mourned by a Mother Earth that dared send 2 of her sons into the unknown. In their exploration, they stirred the people of the world to feel as one. In their sacrifice, they bind more tightly the brotherhood of man." As tension rises and Nixon's speech ends, Safire's masterfully constructed words compare the 2 deceased astronauts with the ancient Greek heroes and other mythological warriors, concluding, quote, "In ancient days, men looked at stars and saw their heroes in the constellations. In modern times, we do much the same, but our heroes are epic men of flesh and blood. Others will follow and surely find their way home. Man's search will not be denied. But these men were the first. and they will remain the foremost in our hearts. For every human being who looks up at the moon in the nights to come will know that there is some corner of another world that is forever mankind.
10, 9, 8.
81.7 seconds after launch from the Kennedy Space Center in Florida on January 16, 2003, a dinner plate-sized piece of insulating foam tore off the Space Shuttle Columbia's orange external tank and impacted the leading edge of the orbiter's left wing at a relative velocity of 545 miles per hour. The energy from the impact was enough to shatter the orbiter's thermal protection system, damage that would later allow superheated atmospheric gases to penetrate the vehicle during re-entry. The entire sequence was caught on camera in slow motion, yet NASA's debris assessment team failed to adequately identify the danger. But what if NASA had conducted an in-orbit inspection of the Columbia and determined that it was impossible to get the craft back to Earth? In a final report on the accident released in August of 2003, a section titled STS-107 In-Flight Options Assessment laid out a startling possibility. The Space Shuttle Atlantis was already undergoing pre-flight checks for a mission to follow 2 months after the Columbia launch. Could the Atlantis have been sent on a rescue mission in time? It would have been a daring attempt, one never tried before, and one racing against the clock to reach the crew of the Columbia before they ran out of air. On February 1st, 2003, the ill-fated Columbia Space Shuttle orbiter and its 7-person crew ended in disaster. On its journey back to Earth, the shuttle broke apart. Famous footage from the time shows the fiery debris shooting high up across the sky as it re-entered the Earth's atmosphere. Wreckage of the space vehicle was strewn across eastern Texas and western Louisiana. This was the second shuttle disaster that NASA had to deal with, some 17 years after the first. The explosion of the Challenger space shuttle just 73 seconds after its liftoff from Cape Canaveral on January 28, 1986, provided some of the most iconic images of the 20th century. The Columbia disaster of 2003 may have been somewhat less infamous in terms of global publicity, but no less shocking. It was a bitter and expensive failure for NASA. The Columbia Accident Investigation Board, or CAIB, would ultimately identify the physical cause of the disaster as damage to Columbia's left wing. The damage had occurred just 81.9 seconds after launch. A small block of insulating foam had separated from the left ramp that connected the shuttle's fuel tank to the orbiter itself. It was then tumbling as the shuttle shook and violently climbed into orbit. The foam crashed against the leading edge of Columbia's left wing, gouging a hole in the shuttle's carbon heat shield tiles. The piece of foam became known as the Flight Day 2 object. NASA scientists ultimately calculated that it punctured a hole of roughly 16 inches in diameter in the panel. This was more than large enough, as analysts would later estimate that a hole as small as 10 inches across could have destroyed the shuttle on its re-entry into Earth's atmosphere. It was only upon its re-entry on day 16 of the mission that the flight controllers monitoring Columbia's descent from Houston noticed erratic telemetry readings from the shuttle. The mission controllers hoped it was just a series of malfunctions on their side, but suddenly all voice and data contact with the shuttle was lost. Finally, re-entry flight director Leroy Kane gave the devastating order to everyone at Mission Control: lock the doors. Those chilling words had only been uttered once before, 17 years earlier when Challenger exploded just after launch. It's what NASA refers to as LOCV, or loss of crew and vehicle. The worst had happened. A second time. What if the Day 2 object had been detected? The foam debris known as the Day 2 object remained unrecognized by the Air Force Space Command, or AFSPC, during Columbia's 16-day mission. There wasn't any perceived threat until atmospheric entry, which made it impossible to address the issue while in orbit. But what if NASA had detected the threat? Would NASA have been able to somehow save the crew? That was the exact question that the Columbia Accident Investigation Board posed. The CAIB asked NASA to develop a theoretical repair and rescue plan for Columbia based on the big what if. That is, what if the detached foam debris and the extreme danger had been detected early in the mission? NASA set about answering that question by laying out a comprehensive plan to rescue Columbia, set to appear at the end of the CAIB report as Appendix D13. The fortuitous other shuttle. The plan to rescue the crew of the Columbia may have been possible due to one important fact at the time. While Columbia was still in orbit, the Atlantis shuttle was already undergoing preparation for flight. It was scheduled to launch on March 1, 2003, only a few weeks later. Atlantis was stationed at the Kennedy Space Center in the Orbital Processing Facility 1, designated OPF-1. Its 3 main engines had already been installed, but it didn't yet have a payload or remote manipulator arm in its cargo bay. NASA needed 2 more weeks of refurbishment and prep work on Atlantis before securing a pair of rocket boosters and a tank onto it. Ensuring that a shuttle is ready to launch is an incredibly complicated procedure that involves millions of highly technical, often minuscule steps. Pulling the launch of Atlantis forward would have meant deciding which steps to skip without endangering the rescue crew. Furthermore, fueling would have become more hazardous and equipment less thoroughly checked. Work shifts would become much longer and tougher on personnel, which in turn could lead to fatigue and procedural oversights that could potentially have catastrophic consequences. For the rescue plan, NASA planners realized that the most pressing supply issue for the astronauts was running out of suitable air, as their cabin began to become too saturated with carbon dioxide. Due to stringent weight considerations on board any space vehicle, so-called spare air is limited. A space shuttle carries supplies of liquid oxygen and liquid nitrogen, which convert into gas and get cycled into the cabin's air to maintain the needed 78% nitrogen to 21% oxygen mixture. To achieve a breathable atmosphere, exhaled carbon dioxide must be removed from the cabin. For this reason, air inside the shuttle is filtered through canisters filled with lithium hydroxide to achieve this. Columbia was equipped with 69 of these canisters, which meant enough clean air until Flight Day 30 of the mission, or February 15th. The timeline-related pressure for getting the Atlantis rescue mission absolutely spot on would have been immense. This would have equated to unrelenting, brutal weeks of 24/7 shift work for everyone involved at Kennedy Space Center with no margin for error. Adding to the theoretical pressure, there would be no practice countdown for the astronauts chosen to fly the mission, nor would there be extra fuel leak tests. The docking of Atlantis with Columbia would itself have prevented myriad challenges. To achieve docking, Columbia would have to be oriented tail first and upside down relative to the Earth, and Atlantis would have to approach right side up beneath it. Atlantis would then swing slowly up into place. The rescue shuttle would have to ease to a halt 20 feet from Columbia. Atlantis would be positioned at 90 degrees to Columbia, which would keep the vertical stabilizers of both shuttles from hitting each other. The mission control logistics necessary to achieve all of this would have been immense, since they would have represented the first time 2 space shuttles were simultaneously orbiting. That would demand 2 separate mission controls on Earth running cohesively and simultaneously. And what about the crew? Since there were already 7 astronauts on Columbia, a maximum of only 4 astronauts could therefore be allotted to Atlantis. After all, the latter shuttle would have to accommodate all the astronauts back home. Yet despite all these gargantuan what-ifs, NASA believed it could be achieved. The final report also considered if Columbia had docked with the International Space Station, which was already in low orbit at the time, and would have had more than enough space and food on board to accommodate the stricken shuttle's crew. Unfortunately, this was not feasible, due to what is known in orbital mechanics as a plane change maneuver. This shift in orbital direction would have required that Columbia apply thrust to shift, seeking to match the inclination of the ISS. The energy required just to execute that maneuver would be too great, and Columbia didn't have enough fuel. Finally, there was an important assumption that Appendix D13 in the CAIB report did not address. If Columbia was so catastrophically disabled by a foam strike, then what would have been the contingency plan for Atlantis should the same have happened to it as well? As the CAIB report somberly concludes, quote, "It is important to note at the outset that Columbia broke up during a phase of flight that, given the current design of the orbiter, offered no possibility of crew survival." Planning for every worst-case scenario conceivable is what the people at NASA are all about. Leroy Kane, the NASA flight director on duty when Columbia was lost, clearly made this point when he said that, quote, "What-ifing is still an integral and very serious part of preparation for any space mission the agency undertakes." Kane would state that, quote, "We went through many difficult failures and tried out many recovery procedures in training, and that prepared us to react constructively to a real crisis." He even added that, quote, "In hindsight, we now know that many of the things we did were futile. On a different day, they wouldn't have been." The rescue plan aside, the CAIB report made damning critiques of NASA's pre-launch and post-launch decision-making. It condemned the hierarchical and territorial nature at NASA. It wasn't the first time NASA had been criticized for this. The same condemnations had occurred in the aftermath of the Challenger disaster. Nevertheless, Appendix D13 of the CAIB report into the destruction of the Columbia Space Shuttle is a well-informed and meticulously researched exercise in what-if. Although pure speculation, it was compiled by engineers and scientists who are intimately familiar with the shuttle program. However, the same CAIB report still concluded that those 7 astronauts aboard Columbia were almost certainly doomed from the moment that the foam block dislodged itself. A rescue plan to save the crew may have been nothing more than an elaborate pipe dream.